All right, in this lesson, we are going to discuss the center of mass. And the center of mass is just the point on which an object can balance horizontally. So it evenly distributes its weight, so it won't go toppling off a pinnacle or a point. So in this picture, you've got the point being the person's finger, and then you've got this bird's beak, happens to be the center of mass. And you can see that's the center of mass because the wings are sort of out and a bit forward, so they balance out the back part of the bird. So a simple situation where we talk about center of mass is with a lever and a fulcrum. And two particles with the masses of m1 and m2 are placed on the lever. That should say lever right there. Sorry about that, guys. So the fulcrum is the point, effectively, that's going to be placed underneath this lever such that the rod, will balance horizontally. So the heavier mass, you need a shorter distance, and the lighter mass would take this longer distance. And that's because the rod balances if this equation holds, that the mass 1 times the distance 1 is equivalent to mass 2 times distance 2, where the distances are the distances from the fulcrum, or the point where we're balancing. Okay? The expressions m1 d1 and m2 d2 are called the moments of each of the masses. And the moments will come up a lot during this lesson. We will need them. And we're going to say that the first distance is basically x bar, and this bar should be up here and not down here. Not sure how that printed funny, but x bar minus x1. And the second distance is going to be x2 minus x bar, where x bar is the center of mass. That's going to be right here. So it's kind of like going in order. You'd have x1, x bar, and x2. So the distance 1 here is going to be x bar minus x1, whereas distance 2 over here is going to be x2 minus x bar. So if we want to find an expression for just x bar, where there are two masses placed on the lever, here's how we're going to do it. We know that m1 times d1, where d1 is x bar minus x1, has to equal m2 times d2, where d2 is x2 minus x bar. And then we can do a bunch of algebra to sort this out, but it basically means distributing here m1 x bar minus m1 x1 equals m2 x2 minus m2 x bar. And then I'm going to add to get the x bars on the same side of the equation. So m1 x bar plus m2 x bar. And I'm going to subtract to get everything without an x bar on the other side of the equation. So m1 x1 plus m2 x2. Basically, what I can do now is factor out an x bar on the left and then divide by m1 plus m2. So I'm going to have x bar equals m1 x1 plus m2 x2, all divided by m1 plus m2. And notice that m1 plus m2 is the sum of the masses of the particles. Okay, so let's do an example with this and just show how it works. Basically, if we have n masses along an x-axis, so put it on the coordinate plane, and we want to calculate the center of mass of all of them, this is obviously more complicated than just having two particles, each with its own mass, and balancing on a lever or on a rod. Now we have to work with the generalized expression for x bar, or we have to generalize the expression for x bar to be n particles instead of just two particles. And so what we're going to say is that x bar is equal to the sum from I equals 1, which is the first particle, to the nth particle of the first mass, or the ith mass, times x sub I, which is, of course, the distance of that mass from the center of mass. So you're taking the sum of all of these m times x's, and you're going to divide it. Remember, here we divided by the sum of the two masses. Now we're going to divide by the sum of all of the masses. So we're just summing up m sub I there. And then what we're going to say is that the sum of m sub I is just m, the sum of all masses in the system, little m. And so our equation becomes the summation from I equals 1 to n of m sub I, x sub I, divided by m, the sum of all the masses in the system. And in this situation, we have, remember I referred to the moment earlier, this numerator here, we can rename as big M. That is the moment of the system, okay, around the origin, whereas M is the sum of the masses in the system. Okay, and we're going to go on to the next video to do the next page.